Welcome students. Today we are going to see the second experiment, and that is the demonstration of colloid mill, planetary mixer, fluidized bed dryer and freeze dryer. So as you know, the aim is demonstration. Okay, we are going to see the demonstration means how the equipment is going to work and what is its construction and what is its principle of operation. Okay, so for that the requirement is you need to have a colloid mill, a planetary mixer, a fluidized bed dryer and a freeze dryer. Okay, so now let's start with the colloid mill. The name itself is suggestive that it is a mill that means it is used for grinding purpose. Okay, so that is size reduction. So the mill, it works on the principle of attrition. You already know, we have already covered this. So attrition is a mechanism of size reduction. So the colloid mill, it basically consists of two discs. Okay, in between these two discs it has a clearance. Okay, clearance is the area where the particle it can move. Okay, so out of this two disc, one disc is rotating. The disc which is placed on the top part, it is rotating, and the disc which is the lower disc, it is stationary. Okay, so when the material is passed through this disc, it will get sheared in between these two discs. Okay, one is stationary and one is rotating. So when you feed in the material in these two discs, because of the movement of the upper disc, there occurs attrition in between the two flat surfaces of the disc, and the particle it undergoes size reduction. So the coarse particle, it is broken down to small particles because of the shear. Okay, now this is the basic diagram of a colloid mill. Now if you can see here, this is the inlet. From here you are going to feed in the material. This is the rotor. Okay, and this is the stator. Like we have seen that in the colloid mill, one disc is stationary, one is rotating, right? Now this disc it is stationary, and this disc it is rotary, right? So when you feed in the material, it will move through this gap and it will come in between this clearance. Okay, so what will happen? This is the rotor. Okay, because of this rotor, this disc it is in rotating motion. Okay, so when the feed will come in this clearance area, because of this rotation, it will get sheared, right? So once the feed is sheared, it will come into this portion and it will be removed through this outlet. So this is the basic construction and working of the colloid mill. Okay, so again, if you see this diagram, this is the hopper, this is the rotor, and this is the stator. Now here the size reduction will take place in between these gap. Okay, so here in this type of mill, this is the clearance, right? So once the material is size reduced, it will be removed. Okay, so this this rotating disc, it is connected to this rotor. This is the belt, and it is connected to the motor. With the help of this motor, this rotates. Okay, so the principle of this colloid mill is that it works on the principle of rotor and stator. Okay, in between this rotor and stator, the particle gets sheared, hence the size reduction, it occurs by attrition. Okay, so size reduction is affected due to the shearing. So when the material is passed between the narrow gap of the milling surfaces of the rotor and the stator. So the rotor, it is made to run at a speed of 3000 to 20,000 rpm. The high levels of the hydraulic shear, it is applied to the process, so the liquid structure gets disturbed. Okay, so based on a rotor rotating at a high speed and very close to a conical stator, the particle size is reduced by modifying the gap. Means how much you want the particle size to be reduced. If you want a little coarse material, or if you want a very fine particle, then you have to modify the clearance in between the rotor and the stator, right? So now let us see the construction. The colloid mill, it consists of an inlet hopper which is used for feeding the material into the mill. It consists of a high-speed rotor and a stator with a conical milling surfaces between them. So there is an adjustable clearance ranging from 0.002 to 0.03 inches. So with the help of this, you can adjust the gap. Okay. So now the rotor will rotate at a speed of 3000 to 2000 rpm. The material to be ground, it should be pre-milled as finely as possible to prevent damage to the colloid mill. Then the rotors and the stator, they may be either they may have smooth surface or they may have rough surface. Sometimes the surface of the rotor and the stator, it is grooved. Okay. Now, why we want rough surface or why do we want grooved surface? Because it will provide more resistance for the motion, and because of that there will occur more size reduction. Okay, so with the rotor and the stator, there is a thin uniform film of material between them, and it is subjected to the maximum amount of shear. So it consists of an outlet which is used for discharging the reduced particles. So if you see this, this is the equipment. This is the hopper. This you can even jacket it with the cooling water circulation. Okay, because in colloid mill, because of the shear, okay, or because of the attrition, there high amount of heat is produced. Okay, so if your material is very sensitive to the heat, then we can even jacket it with the cooling water. Okay, so that the heat will be removed and your material will not be damaged. Okay, so here for that purpose there is a cooling water joint inlet. Okay, this is the adapter plate, this is the handle, then this is the motor. Okay, this is the power port, this is the support, this is the lifting cover, you can lift it. Okay, from here, once your product it has grounded here, it will be removed from this discharge port, right? So this is the same equipment, this is the charging point, this is the stator, this is the rotor, and your product will get sheared in between this clearance and the product will be discharged from here. So the working of this colloid mill is the material which is to be milled, it is placed into the mill through the inlet hopper. It is then passed through the narrow gap between the rotor and the stator and thus reduced to the fine particle size. A colloid mill is a hydraulic shear producing device. The colloid mill, it works to reduce the size of the suspended droplets. The mill allows the solid particles to become so small. The process of colloid milling is done through the addition of the heavier liquid into the chamber of the mill that performs the shearing process. So once the heavier liquid it has been added, the lighter material, whether it is a solid mass or if it is a liquid of different viscosity, it is added next to the material and then the mill is started. Now what is the purpose of this? Okay, why do we add the liquid? Because using the colloid mill we can directly produce the suspension or the emulsion. Okay, so when the milling portion of the function it takes place, the materials they are both stirred together within the mill at a very high rate of speed. Okay, so the suspended particles they are thus size reduced, and you all know that whenever we want to prepare any type of emulsion or a suspension, we want that the dispersed phase it should have minimum particle size, then only we get a pharmaceutically stable formulation. Okay, so now the advantage of this method is it has got high throughput with excellent grinding result. It is infinitely adjustable gap settings between rotor and stator for controlling the particle size reduction. Then it is suitable for products of high viscosity range. It is capable of operation under pressure up to 16 bars. It is very easy to clean and operate. Then you get fine grinding. Okay, so the particle size, the smallest particle size which you can receive using this colloid mill is up to 3 microns. It is good for fibrous materials as well. It is less noisy. The disadvantage of this method is it has got high power requirement for running the mill. It consumes more energy. The wet materials needed for you need wet material for grinding. Then due to shear, heat is also generated. It is not very suitable for thermolabile material. Now last we will see the applications. It is used for dispersion of the solid particles into the liquid. Uh, Reduce the particle size in, which will reduce the particle size in the suspension in a liquid, or it will reduce the droplet size of the liquid which is suspended in another liquid. Then to increase the stability of suspensions and emulsions, we can carry out this process at the end. Why the stability will increase? The reason is that the particle size, it will get reduced. Then for emulsification, homogenization and dispersion and mixing, this meal can be used. Then it is also useful in the manufacturing of food pastes, emulsions, coatings, ointments, creams, pulps, grease, etc. And the colloid mill, it can be sterilized, so it is mainly used in production of sterile products. Now we will see a video in which the construction and working will be further clarified. Now we will see the video. Now let us see next equipment is the fluidized bed dryer. Dryer, as it is dryer, it is used for the process of drying. Okay. So fluidized bed dryer, it can be either designed for batch operation or it can be either designed for continuous type of operation. So here the material which you want to dry, it is first placed in a vessel, and this vessel or this bowl, it has got a perforated bottom. Okay, now through this bottom, air or any other gas, it is passed under very high pressure. Okay, now as very high pressure air is moving through this perforated bottom, the solid which is placed in the bowl, it will start to get flow, or it will get lifted with the pressurized air. And because of this, the particles, as they will float in the air, they are said to be in the fluidized state, right? So the particles, because they are in the fluidized state, as they are suspended in the air, they become surrounded by air or the gas from all the sides. Okay, now as your single particle is surrounded by hot air or hot gas from all of its sides, then drying will be very efficient. So the air or the gas, it picks up the moisture from the solid and it moves into the cyclone. So the dried solid is then removed from the vessel after it attains ambient temperature. Okay, so now let us see the construction. This is the inlet for the air, this is the outlet for the air. This is the recirculation control. This is the air heater. This is fan. This is filter bag. This is detachable ball. This is the fluidized solid. Right now, you can observe here. This is the inlet for the air. Okay, this is the inlet for the air. From here, the air will move in. At this point, a filter is placed, right? So the air which is coming inside this material, it gets filtered first, then the air will move through these heaters, right? So what we have done, we have filtered the air here and we have allowed the air to move through the heater, right? Now because of this air heater, the air will get heated. Now this heated air, it is allowed to move under high pressure through this screen, and it will come inside this space, right? And from here, as you can see, this is the detachable ball and this is the perforated bottom of that ball, right? Now from here, the material, sorry, the air, it will move up, and along with it, it will carry the solids, right? So the solids, they will be in the fluidized state, and because of the air, because of the particle will be surrounded on all of its side by the air, it will be dried efficiently, right? Now the air will move through this back filters. Okay, so in this material, so the material which we have, which we want to dry, it will contain some very fine particles as well. Okay, so those particles, they will be carried along with the air through this back filters, right? Now what will happen, this back filter, it is made up of cloth. Okay, so the air, it will cross, it will move across this wall, cloth wall, but the fine particles, they cannot move outside this bags, they get entrapped into the cloth fibers, right? So what happens, after some interval of time, you have to intermittently shake this uh, bags, so that the particles which have stuck inside this vessel, they will again fall back into your material, right? And the air, because of this fan, the fan is in continuous motion, it provides good circulation, and the air will be removed from this outlet. Okay, so this is the normal construction and working of the fluidized bed dryer. Now we will see the construction in detail. Okay, there are two types of fluidized bed dryers. Either it is vertical fluidized bed or it is horizontal fluidized bed dryer. So the construction of the vertical fluidized bed dryer is made up of stainless steel or plastic. Then the detachable bowl is placed at the bottom of the dryer, and this detachable bowl is used for charging and discharging of the material. Okay, the bowl, as we have seen already, it has got perforated bottom, and there it has got, we have placed a wire mesh which will support the material, okay, which we want to dry. So the fan is mounted in the upper part for circulating the hot air. There is fresh air inlet, there is pre-filter, and there is heat exchanger or air heater. Okay, These are connected serially to heat the air to the required temperature. Hmm. So the temperature of the hot air and exit air, they have to be monitored. The bag filters, they are placed above the drying bowl for the recovery of the fines which are present in the material. The airflow is adjusted by means of a recirculation control, and the fabric bags, they are provided to prevent the passage of the fine particles. So this type of fluidized bed dryer is a batch type dryer. Okay, and the drying chamber, after the drying has been completed, you have to remove it, and again you have to remove the material, then again you have to charge and you have to place it in the dryer, right? So different capacities ranging from 5 kg to 200 kg with an average drying time of 20 to 40 minutes of the fluidized bed dryer are available. The horizontal vibrating conveyor fluidized bed dryer, they are used for continuous drying operations of a large volume of the material. Okay, so now let us see the working. The wet granules which are to be dried, they are placed in the detachable bowl. Okay, the bowl is pushed inside the dryer, so fresh air is allowed to pass through a pre-filter, which will be subsequently passed through the heater and it will get heated. Okay, so the hot air flows through the bottom of the bowl. Simultaneously, fan is allowed to rotate. So the air velocity is gradually increased. So when the velocity of the air is greater than the settling velocity of the granules, they remain partially suspended in the gas stream. So this condition is called as fluidized state. The gas surrounds every granule to completely dry them. The air, it will leave the dryer by passing through the back filters. The entrained particles, which are very fine particles, which remain adherent to they will remain adherent to the inside of the surface of the bags. Okay, so periodically these bags are to be shaken to remove the entrained particles. So there occurs intense mixing between the granules and the hot gas, and it provides uniform conditions of the temperature composition and particle size distribution. So drying is achieved at constant rate and falling period is very short. So any attempt made to increase the air velocity, it might result in more entrainment of the fine particles. So the residence time for the drying is about 40 minutes. The material after drying or after completion of this cycle, it is left in the dryer for some time so that it will reach its ambient temperature. After that, what you have to do, you have to take out the bowl and you have to discharge the material. Now let us see the advantages of FBD. It takes less time to complete the drying. That is, the drying occurs in 20 to 40 minutes as compared to the 24 hours of tray dryer. The drying containers, they are mobile, making handling simple and reducing the labor cost. The thermal efficiency is 2 to 6 times greater than the tray dryer. Okay, it is also used for mixing the ingredients and its mixing efficiency is also high. Hot spots are not observed in the dryer because of its excellent mixing and drying capacities. Higher drying temperatures can be used that are not possible in the tray dryer. And lastly, it facilitates the drying of thermolabile substances. Since the contact time for the drying is very short, it can be used either in the form of batch type or continuous type. It has a high output from a very small floor space. The disadvantage of FBD is that many organic powders, they will develop electrostatic charges during the process of drying, and to avoid this, efficient electrical earthing of the dryer is essential. The turbulence of the fluidized state of the granules may cause attrition of some materials, resulting in production of fines. The pharmaceutical use of FBD is that it is used for properly drying of the granules in the production of the tablets. It is used for many operations such as mixing, granulation, and drying. It is modified for coating of the granules as well. So now we will see a video about this FBD so that our understanding will be further clarified. Now students, we will see the next equipment, and that is planetary mixer. The name is itself suggestive that it is a mixer, so it is used for mixing purpose. Okay, so the principle of this planetary mixer is that it works on the principle of shearing and convection action. Okay, this mixer, it is designed especially for semisolids, paste, ointments, viscous material, pill mass, and tablet granulation mass. Okay, when we go for tablet granulation by wet method, at that time we use planetary mixer. So you can say in generalized statement, you can say planetary mixer is used for semisolids only. Okay, so it is used, but it can be used for both dry and wet mixing as well. Okay, but mainly it is used for wet mixing. So this mixer, it is designed in such a way so as to provide intensive mixing, dispersing, and kneading of the products. The equipment, it gets its name by the fact that the blade of the mixer, they move in two ways. Okay, so the blade, it rotates around its own axis and around the central axis, just as the movement of the planet in this planetary system. You all know that all the planets, okay, which are present in the solar system, they move, they rotate, they revolve around its own axis, and it also rotates around the sun. Okay, so this part is fixed. Okay, every planet, it moves in this fashion. So the blade which we are going to use in this planetary mixer, it moves in the same two directions, that is, it rotates around its own axis, and also it is going to revolve around the central axis. Okay, so hence this equipment, it gets its name as planetary mixer, because the movement of the blade is similar to the planets in the planetary system. Okay, so due to such motion, there is no problem of dead spots. Okay, dead spot is a place where there occurs no mixing. Okay, so because of the movement of the blade, as well as the movement of the rotation of the blade and movement of the blade into the container, there is no dead spot present in this mixer. Okay, so in this mixer, the blade, it causes tearing of the material, and shear is applied between the moving blade and the stationary vessel wall. The blade, it has plates, okay, which are in slanting direction. Okay, now there is purpose why this blade, it has got slanting direction, or the plates, why the plates in the blade, they are arranged in slanting direction. Okay, so what happens because of this direction, the material, okay, when you put the blade into the material, because of the rotation and revolution of the blade, it starts to rise up. Okay, the material, it will rise up to a certain length of the blade, and then it will tumble back into the container. Okay, so this tumbling motion, it is obtained here, which further helps in thorough mixing of the material. Hence this planetary mixer is very unique in its operation. Okay, so this is an example of planetary mixture, and this is used in the industrial scale. Now you can see here, this is the blade. Okay, and it has got this plates. Okay, here they are not slanting, but in most of the cases they are arranged in slanting direction. Right, now first we will see the construction and operation. The planetary mixer, it consists of a mixing bowl, a blade, and a motor. Okay, the bowl, it is vertical, cylindrical, stationary, and is held in place with a semicircular frame. The bowl sizes, it varies as per the capacity of the mixer. The bowl can be removed either by lowering it beneath the blade, or you can raise the blade and then you can take out the bowl. Okay, so there are various types of blades available depending on the purpose or a type of the product which you want to mix. But the blade, it is constructed in such a way that there is a close clearance between the sides, bottom, and the blade, so as to get uniform mixing and to avoid the generation of the dead spots. So the blade, it has, as we have already discussed, it has got two movements. One, it is around its own axis, and the other, it is around the central axis of the vessel. So these both the movements are in opposite direction. Okay, so this type of movements, it avoids development of the dead spots. So to get such planetary motion, the blade it is connected to a gear pinion, which is in turn connected to a stationary gear ring. The gearing is built with variable speed drive. Low speed is used for dry mixing and high speed is used for wet mixing and kneading. Sometimes self-aligning scrapers too are incorporated into the bowl. Now, what is the use of the scraper? You all know that the scraper it removes the material which sticks to the vessel wall, and again it comes into the circulation or it comes into the process of mixing. Okay, now let us see the working. So first, what you have to do, you have to load the bowl with the material, then the mixer is rotated. Okay, you place the bowl in the position and then you make the mixer to start, okay, to rotate. Okay, initially you are going to rotate it at a low speed, okay, and this will give you a pre-mixing process, and then slowly you have to go on increasing its rpm. Okay, when you increase the rpm, you get thorough mixing. So the, as you all know, the blade it rotates in two ways, so we get uniform blend without any dead spots in the vessel. Also, as the blade they rotate, due to the plates of the blade, the material it is going to rise slowly over the blade and then it will fall back into the vessel. Okay, so this is the tumbling action. So because of this tumbling, what happens, there occurs uniform mixing. So after the mixing is done, the mixer is switched off and then the bowl is lowered or the blade is raised and the bowl is removed. So the material it can be removed by scooper or just by dumping. Okay, now if you see this diagram, this is the stationary ring, okay, on which to which the blade mixer blade is connected, right? This is the blade, this is the planetary gear, this outer circumference is the ring, this is the direction of the drive. Okay, means this whole blade it will move in this direction. Okay, and this is the rotation, direction of rotation of the planetary gear, means the lower part of the blade it will rotate in this direction, right? So if you see here, the movement is opposite, the blade is moving in this way and the shaft is rotating in this way, right? So because of this, now you can observe, as this blade it will rotate around its shaft in this anti-clockwise direction. Because of the movement of the blade all through this vessel wall, what is going to happen, there will be no dead spots created in this mixer and you'll get a thorough mixing. Okay, so because of this planetary sort of movement of this blade, mixing is very efficient, and hence this mixer is mostly used for production of semi-solid products. Now let us see the advantages of the planetary mixer. It is simple to construct, it is easy to operate, and it is very easy to clean. Okay, so it is relatively cheap. There is virtually no dead space in the mixing bowl. The disadvantage of this mixer is that it requires high power, it has limited size and is only useful for batch work only. You cannot make it to work for continuous operation. The application of planetary mixer is that it is, as I told you, it is ideal for semi-solids. Now what includes in semi-solids? Creams, ointments, ceramics, colors and pigments, resins, ink, cosmetic creams, herbal creams, viscous or heat sensitive and cohesive paste, dough, etc. The planetary mixer, they are also ideal for mixing and kneading viscous pastes under atmospheric or vacuum conditions. So this is the actual principal construction and working of planetary mixer. Now we will see a small video and we will, so that it will clarify further what is the construction and working of the planetary mixer. Okay, now we will see the video. Now we will see the last equipment, and that is the freeze drying equipment. Okay. Now drying, again, it tells us that this equipment is used for the process of drying. Okay. So freeze dryer, it works on the principle of freeze drying. Okay. The freeze drying is also known as lyophilization, gelsification, or drying by sublimation, or cryodesiccation. So these are the different names which are going to suggest you that it is a freeze dryer. Okay. So it is a low temperature dehydration process which involves freezing the product. Then first you will freeze the product, then you will lower its pressure, and then the ice, it is removed by sublimation. Okay. Now what is sublimation? Sublimation is the transition of a substance directly from solid to the gas phase without passing through the intermediate liquid phase, right? So the water moves from solid state to vapor state without being converted into the liquid state. Okay. Now this process, it can occur only below the triple point of water. Now, what is the triple point of water? It is the condition, it is a specified condition of temperature and pressure. Okay. Below this point, the water is going to behave in a different way. Okay. So that triple point condition is of 4.579 mmHg pressure, and its temperature is 0.099 degrees Celsius. Okay. So the triple point is the temperature and pressure at which the solid, liquid, and water, vapor phases of a particular substance, they coexist in equilibrium. So in pharmaceutical products, the liquid contains dissolved solutes, and due to this there is change in the temperature and pressure conditions at which there will occur sublimation. So in such case, the point of the particular temperature and pressure at which direct conversion of solid to gas will occur is called as the eutectic point. Okay. Now triple point is different and eutectic point is different. Okay. Triple point is described only for single pure water, whereas when any type of solution is present, okay, like any solute is dissolved in water, at that time the change in the the change in the temperature and pressure of the triple point. Okay, here the triple point will be called as eutectic point. Okay, so the product is subjected to conditions well below the eutectic point to avoid melting. Okay, and then any heat which is given or which is supplied to that particular material, it will cause sublimation of the ice. Okay, so water vapor formed is made to condense in a cold trap which is maintained at a temperature much lower than the frozen material. Okay, if the condenser is maintained at the temperature below than the material, then and then only there will occur condensation of the vapor, right? So in freeze drying, material is frozen first, then it is subjected to heat in any form like radiation, conduction, or both under high vacuum. Then it will result in sublimation of the frozen liquid, leaving behind the solid or the dry components. So here three things are very important. First, the vapor pressure of water at the surface of the solid, it must be high as compared to the partial pressure of the enveloping surrounding. So this is a driving force for water vapor. Secondly, heat must be provided at a constant rate in such a manner that the temperature rise desirable both at the surface and in the interior. Okay. Thirdly, a system should be incorporated to remove the water vapor. We are going to install the condenser here. Okay. Now this is the diagram. Okay, or you can say this is the diagram for triple point. Okay. Now if you see here, this is the pressure condition of 4.579 mmHg, and this is the temperature of 0.099 degrees Celsius, right? So this is the triple point. Okay. Now if you observe above this triple point, in the solid ice, if the temperature is increased at particular pressure, then it will be converted from solid to liquid, right? So this is called as the fusion curve. Now, if you observe the behavior of water in this range, okay, then what will happen? Suppose at this particular pressure, temperature is this. If you further increase the temperature, then the liquid will get converted to vapor phase. right? Now, if you see this, what is going to happen? If this is the initial temperature, sorry, this is the initial temperature and this is the initial pressure, right? If you decrease the pressure at this point, then what will happen? Sorry, if you decrease the temperature, then the vapor, it will get converted to solid ice directly. Same is the process reverse wise. What will happen? If you maintain the pressure at this point, okay, and if you go on increasing the temperature, then what will happen? This solid ice, it will get directly converted into the vapor phase, right? So the conversion which occurs from liquid to liquid water to vapor on this axis, on this curve, it is called as vaporization curve. And this curve AC, from where the solid ice will be directly converted to vapor, it is called as the sublimation curve. Okay, so this triple point is very important. Okay, so any point below the triple point at which there occurs direct conversion of solid phase to liquid phase is called as eutectic point only in case of solutions, right? So let us see the construction of the freeze dryer. It consists of four basic components. One is the vacuum drying chamber. Second is the vacuum source. Third is the heating source. And finally, the vapor removal system, which is your condenser, right? So the vacuum drying chamber is constructed mostly for batch operation. It is connected to a source of vacuum. Okay. Inside the chamber, shelves are arranged. Okay, so that on this shelves you can place the material. Near the chamber, you have to place a condenser. The distance between the two, that is the shelf or the material and the condenser, it has to be very small as compared than the mean path of the molecule. This will facilitate faster the rate of drying process, right? So condenser is mostly in a form of pipe of small diameter to have large surface area for condensation, and for this purpose this condenser it is available in the coiled form, right? So the temperature of the condenser is kept lower than the solid surface with the help of solid carbon dioxide slurred with ethanol or acetone. The condenser, it has to be cleaned up intermittently to maintain the temperature gradient. Okay, the condenser, it can be cleaned by circulating heated fluid through it, so that all the material, all the fluid which is attached to it, it will be removed. So this will readily melt the ice, or scrapers can be incorporated for the same operation. So this is the freeze dryer. It is the shelf. Okay, sorry, it is the chamber. This is the door, you have to open it. Shelves are placed here. The shelves, they are placed so that you can keep the material in this chamber, right? So this is the drying chamber. Here is the heating system is attached below the chamber. This drying chamber is connected to the condenser. This is the condenser. As you can see, it is in the coiled form, so this will increase the surface area. Okay, and it is connected to a source of vacuum. Okay, so the construction is very, very simple. Let us see the working. The operation of the freeze dryer, it involves many steps. As first, you will have to pre-treat the sample, then you have to freeze it, then there occurs primary drying, nextly secondary drying, and last step is the packaging. Okay, so now let's see what is the pre-treatment. So these are the processes done before the freezing of the product. Okay, this might include concentrating the product prior to freezing by subjecting it to normal vacuum tray drying. It also helps to reduce the actual drying by 8 to 10 times. Okay, because here little amount of water will be removed as we are concentrating the fluid. Okay, so also this pre-treatment, it helps us to get a porous final product. Sometimes to increase the stability or appearance of the product, some components are added. So after this, the product is ready for freezing and it is packed in final container, which can be your vial, ampule or bottles, right? So now let us see the freezing process. The material is placed on the shelf in the vacuum, which is the vacuum drying chamber, and it is cooled below the triple point or the eutectic point. Okay, so the normal cooling rate is about 1 to 3 Kelvin per minute, so as to get large crystals of the ice. So these large crystals on sublimation, they will leave large holes, and ultimately we will get a product, a porous product.
So this phase is important because it determines the impact on speed of reconstitution, duration of freeze drying cycle, and product stability. Okay. So now let us see what is a primary drying. So this is the diagram of while during primary drying. Okay. So it is kept on a heated shelf. This is the metal tray. This is the frozen solution, and this is the sublimation interface, and this is the dry solid, right? So this is the direction of heat and mass transfer, and the vapor, it will move to the condenser from here. Okay. So in this stage, what is done? The temperature and the pressure is lowered to a point where the ice will sublime. Okay. If the product just contains water, then it is lowered below the triple point. If the product contains solution, okay, then it is lowered below the eutectic point. Okay. So freeze drying of the pharmaceuticals is carried out at the temperature range of -10 to -40 degrees Celsius, and pressure, it has to be 2200 microns. Okay. When heat is supplied to the product over a larger time span without passing the eutectic or triple point. Okay, means you have to strictly check here that the temperature, it won't go beyond the triple point or the eutectic point. Okay. So the heat supplied in this way, it will act as a latent heat for sublimation, and the solid ice, it will get converted into vapor. Okay, so vapors are formed instantly and these are removed. So the driving force here is the temperature and the pressure difference between the evaporating surface and the condenser. Hmm? Why? Because we have kept the condenser at a much below temperature than the temperature of the material, right? So the temperature difference create a pressure differential, and there occurs net migration of the molecules towards the condenser. So if a product, it has got eutectic point of -10 degrees Celsius, then its temperature may be taken up to -15 degrees Celsius, and the temperature of the condenser, it has to be controlled at -500 degrees Celsius, sorry, -50 degrees Celsius. So here the temperature difference causes faster migration of the molecules. So as freezing continues, thickness of the frozen solids decreases, and that of the dried solid, it will go on increasing. So at this stage, easily removable moisture is completely removed. The product gets dried up to 98 to 99%. Then there occurs secondary drying. So during this stage, the remaining traces, they are removed. The solvent which is removed is referred to as bound water. So here the temperature is raised than that used for primary drying, and vacuum is lowered further. So temperature can even go above 0 degrees Celsius to break any physicochemical interaction formed between the bound water and the frozen solid. So in this case, the rate of drying is very, very slow. And the last step is the packaging. The vacuum is replaced by inert gas, and mostly it is nitrogen before sealing the sample. Then the vials or the bottles, they are sealed, and the final product, it may contain 1 to 4% water as residual moisture. So the advantages of this method is that the entire process is carried out under the conditions of low temperature and pressure. The material retains its chemical composition and stability as high temperature for heating is not required. So hence we avoid the chemical degradation of the material. In this case, we are going to obtain a more stable product. You can also maintain the stability of the product. Product stability, sorry, you can maintain the stability of the product. Product stability is increased, and also it is rendered suitable for reconstitution as porous product is formed. Loss of volatile material is very negligible, okay, as it is free from migration of salts, electrolytes, etc. And also we are not going to use heat, okay, so there is no loss of volatile material. The finished product is obtained as the material. It can be dried in its final container. Due to use of low temperature, the product will retain its nutrients and color. Okay. The disadvantage of this method is that the cost of construction, working, and maintenance is around 5 times higher than the conventional tray dryer method. The time required for completion of the process is large. It cannot be shortened. As the technique of drying is lowering temperature and pressure, the microbes which can withstand such conditions, they are not killed and they survive in the dry product as well. So there is a chance of microbial contamination. Silicon oil is used for cooling of the shelves due to continuous cooling and heating cycle. Silicon oil leakage can take place from the weak areas like connection of the shelf and hose. This leaked oil can damage the product. This method is difficult to employ for the products that do not contain aqueous solvent. Product needs packaging with inert gas because there are high chances of product oxidation due to increased porosity and large surface area. The application of freeze drying is that it is mostly used in pharmaceutical industry to prepare the dosage forms like injections, solutions and suspensions. Also, it is used to preserve and ultimately increase the shelf life of certain products like blood plasma and its fractionated parts, bacterial and viral cultures, human tissues, antibiotics and plant extracts, steroids, vitamins, enzymes, etc. Major benefit of freeze drying in pharmaceutical industry is that the product can be stored in sealed in a vial or bottle after removing its moisture. It can be shipped anywhere and on requirement it can be reconstituted into its original solution form for injection. It is also used in food industry to preserve food and make it light in weight. The astronauts, they carry ice creams in freeze-dried forms. In chemical industry too, freeze drying is used for making a product more stable and liable for reconstitution. It is also used in bioseparation methods. Okay, so this is it. This is about freeze drying. So, so this was the basic principle, construction and working of the freeze dryer.
The freeze dryer freezes the food to 40 degrees below zero. The vacuum pump automatically turns on and creates a powerful vacuum around the food. As the trays gradually warm, while the food is still frozen, a process called sublimation occurs, which removes water from the food. This is what allows the food to keep its original shape, flavor, and nutrition. The process takes between 20 to 36 hours. Smart sensors determine when the food is completely dry and alert you with a beep. The process is entirely automatic.
So in this particular experiment, we have learned the construction working of equipment. So we can say, so we can write in the result that demonstration of colloid mill, planetary mixer, fluidized bed dryer, and freeze dryer, and other major equipment was carried out. So the questions which are likely to be asked on this particular experiment are, you will have to write in detail or you will have to explain the principle of freeze drying. Then question might be asked to explain the principle of fluidized bed dryer. Also the question will be asked to explain the principle of planetary mixer. Then you'll also be asked to write the principle of colloid mill. Also there can be various questions like write the advantages of colloid mill, write the advantage of freeze drying, write the advantage of fluidized bed dryer, write the advantage of planetary mixer. Okay, so these sorts of questions are asked on this particular experiment. So this was all about the demonstration. Thank you for watching.